Um, okay, nice. So the recording started. Uh, as I just said, today is class number 7 of Python 1, so we're almost done. But we have a couple more things to talk about, and but before we do that, we'll go over some review. I think last week I went over a couple of new topics, if statements, and also we looked at coding bat, which is what the homework was about on. And I want to go over a little bit more in depth because I think I definitely rushed the if statements and I might not have explained it too well. So I'm gonna pull up the slides for that again, actually. So let me just open up the slides from last week, and I'm gonna start sharing the screen. Share screen, share screen. So here we go. So the if statements were an example of conditional statements. And so we had this structure of basically, depending on whether a condition is satisfied or not, we'll do one thing. If it's not, we're not going to do it, right? So here's what an example code might look like using the conditionals that we learned last week. The first line, can anyone tell me what this first line is doing in this code? X equals int input, please enter a number. I see, Evan, you have your hand raised.
Basically, it.
Oh, I heard you start, but you got muted.
Oh, okay.
Yeah.
Basically, it's because the input is a string and we needed an integer. So it basically the int is turning the input into an integer so that the elif and stuff can process it.
Yeah, perfect. So I'm glad you remembered. First, this line uses the input function, which is what we use to get input from the user. So whenever we call this input function, our program is going to spit out like a text box or somewhere to type for the user to type in whatever they want. And this please enter input a number, this is just a prompt. So whenever we ask the user to type something, that's going to show up next to it. And then, like you said, Evan, the result of this, once we collect whatever the user typed in, that's initially a string. And a sneak peek is we want to work with this input as a number. We don't want to treat it like a string. We want to be able to compare it with other numbers. And so to do that, we have to convert it to a string, to convert it to an int ourselves. And so that's what this int around the input is talking about. And so whenever you have these nested statements like this, it's, I think, best to look from the inside out, because the inside is what's being done first, essentially. So first the input is run, and then we call the int function around it. So this gets input, treats it as a number, stores it into X, and now we have the conditional statements. And so here is one condition, X greater than 0. So if this is true, we're going to do whatever's in this block of code. Here we just have one line, but it could have multiple lines. We showed it's a block of code because they're all indented the same level. They're indented differently than the if statement. So the if statement is one level, and then everything inside the if is going to be indented one tab character. And if you don't know where the tab character is, it's above caps lock on my keyboard on the left side of the key, on the left side. But that just inserts a tab to shift everything over. And then we have with if statements, we can add the elifs. And does anyone remember what elif stands for? It's kind of like two words that we combined into one. Yeah, thank you, Derek. I see you in chat. Else if. Yeah, so elif just stands for else if. So you can kind of read this like English. That's how Python goes a lot of the time. So if this first condition, we're going to do this first block of code. Else, if that's not true, but if this second condition is true, then we're just going to do this one instead. And then similarly, else, if the other previous ones didn't work, but if this statement is true, x greater than 2, then we're gonna do print larger than 2. And finally, at the end of our conditionals, we can have an else statement that says, if none of the previous things worked, I'm just gonna do this, right? So if I get to this point, I will just do whatever is in this block. Remember, the important things are, it checks the conditions in order. So it does the first one first, the second one second, so on, so on, so on. And it only will execute one of them. So if it does the if statement, and if the if statement is satisfied and it does that block of code, it will ignore everything afterwards. Well, everything part of that same conditional block. So the elifs and the else, it'll ignore them. It will still execute code after that, but if you have like a if else if structure, it will only do one of them at any given time. It could do 0 if you don't have an else though. I'm glad, Evan, I see in chat you have your own way of remembering. That's always good. So yeah, in general, the basic structure is you have if, you have as many else's as you want, elifs. You can have 0, you can have 5, you can have 100, right? They're all followed by a conditional statement. So these things I'll call conditional statements because they're a statement that has a condition associated with it. X less than 0, that's a condition. That's like a requirement for this to be run. If this isn't satisfied, this isn't going to be run. Simple as that. Can anyone tell me what type a condition is? Like if we evaluate X less than 0, what kind of thing do we get? So it's with a B. Might not be clear what I'm looking for. It's not a string, but I'm looking for a data type. A data type that starts with B. Boolean, yeah. Yeah, I see a couple Booleans in chat, that's great. So yeah, the conditional statements, these should all end up being Booleans, essentially. Whenever you evaluate them, you'll get a Boolean. And you have to put like a Boolean expression in these spots, right? Because it doesn't really make sense to say if 0, right? What does that even mean, right? 0 is a number. What is, like, that doesn't make any sense. You have to say like if true or if false, I guess. Well, the thing should evaluate to true or false. So that will tell you if it's true, you will do it. If it's false, you will skip it. Right? And so going to the homework, I think that was the other kind of new thing that we looked at. I didn't explain it super well what's going on here, but I will try to do that a little bit. Actually, this was not the homework problem. This was a homework problem, or at least one of them. So here, what we're actually doing, I didn't explain this last week, but we're creating what's called a function. So we've seen functions before, such as the sort functions, the split functions, the upper functions. We've seen a lot of them. Essentially, what we're doing here is we're writing our own function to solve a specific problem. And so what CodingBat does is they just have a bunch of problems and they want you to write a function that will solve the problem that they give you. So here, the problem is right here. And I saw a couple of you guys solved it, which is great. But I'm just going to read the question out again. In this problem, you're given an array of ints. An array is just the same thing as a list. So you have a list of ints, and you want to return true if the list has a length of 1 or more, and the first element is equal to the last element. Really quickly, does anyone see why we have to care about this condition? Why do we have to care if the length is 1 or more? Oh, Derek, I see you have your hand raised.
Because it says more, so you have to put greater than or equal to, not greater than, because if the length is just 1, then it's also true.
Yeah, so what you said is right. We will have to use like a greater than or equal to. I guess what I was looking for is we have to, I was asking like, we have to check this if the length is 1 or more. Because if this isn't true, what does that mean? That means our list is length 0. And if our list is length 0, then the second part doesn't make sense at all, right? Because if it doesn't have a length of 1 or more, then that means there's no elements. And so it doesn't make sense for the first element and the last element to be equal to each other. Like that's not something we can check because there are no elements, right? And so that's why this first part is important, right? We do have to check if the list has a length of 1 or more. So if we look at the coding environment that they give you, this is definitely something we haven't really talked much about. And this is how you write a function in Python. We're actually going to get into this a lot more deeper in Python 2 if you decide to take it after this. But all you have to understand at this point is that def just says you're making a function. This is the name of the function that you're going to make. So our function that we're writing is called same underscore first underscore last. Since we're not going to be the ones calling the function, it's going to be the auto grader, the person who checks if it's right. It doesn't really matter at this for us. What does matter though is what's inside the parentheses. So what's inside the parentheses is the input to our function. This is what we have access to. So here it says our function takes in one piece of input. It takes in something called nums. And based on the instructions, what do you think nums is, right?
A variable?
Yeah, it's a variable, but specifically what kind of variable? Look at the instruction. What is the input to our problem?
The answer?
So that's the return, and we're going to get to that. The input to our function, or the input to our problem, is actually this array of ints. So when you read this problem, you have to think, what are we given and what do we have to produce, right? So here we're given an array of ints, a list of ints. So that means this thing is what that list of ints is. So Derek, you're right, this is a variable. This variable stores a list of ints. We know that because of the problem, right? Because of the instructions. That's the only way we can figure out from here. So we have this input nums, which is an array of ints. Now we have to figure out how to produce an output. And it says the output should be true if it's length 1 or more and the first and last elements match. And it should be false otherwise. Right. And so it gave a couple examples here actually. So if you call this function on the list 1, 2, 3, this should clearly return false because the length is 1 or more, but the first element is 1, the last element is 3. So clearly they don't match up to each other. So this returns false. The second one returns true because the length is 1 or more, which is what we want. And the first element is 1, the last element is also 1. So their matchup, we're good. Right. And so to solve this problem, I kind of wrote up some steps. If you've already solved this, probably everything I've seen, like people generally follow this pattern, I guess, or these steps. You can also merge some of these together. In Python, a lot of times you can write really compact code. I wouldn't recommend that for starting out, just because it can cause more trouble than it needs to. And really, we don't really care about how many lines of code or whatever, how long your program is. We just really care about, does it work or does it not work? Right? So oftentimes, especially when you're starting out, it's better to just write more than less, right? Better to be more careful than to be as short as possible. So the first step is we have to check if the length of the array is 1 or more. And I put stars around if because spoiler, we're gonna need an if statement. And nums here is, again, this is our input. This is our list. So before I write the if statement, can someone remind me, how do I find the length of a array? How do I find the length of a list? Maybe put in chat the piece of code. It's not going to be the full line that I need, but just a piece of code to find the length of nums. Okay, yeah, so Derek put the len function. And so it's going to be len, and then you put nums inside the parentheses. And that gives you the length of the array. So we need an if statement. I say that. So something that looks like this, and we have a condition. So can someone, let's have someone new. What should this blank be? I want this to be when the length is 1 or more. So we want to go inside the if the length is 1 or more, and the else is for when it's not. So Evan, I see you have your hand raised. Do you want to give the answer?
Basically, if length of nums is greater than 0 and
Okay.
nums,
I agree with this. So this is one way you could do it. Evan said, if len nums is greater than 0, this will be true if the length is 1 or more, and this will not be true if it's not 1 or more, right? So if this is true, then we know that the length is 1 or more. And so this may or may not be what you thought of, what everyone thought of immediately. I'd say this is one way. Another way would just be to say literally greater than or equal to 1. This is more like what the instructions told us. This is more like what the English said. This is a more, I guess, compact way. They're equivalent because lengths of lists we know are integers. You can't have a list that's like 1.5 or 0.3, right? Lengths are integers. And so being greater than 0 is the same thing as greater than or equal to 1. And so both of these work. I agree, this is perfectly fine to have. So now that we know the length is greater than 1, we want to get the first and last elements out of our list. And I think getting the first element is pretty easy. Getting the last element, there's an easy way and there's a little bit of a longer way. So to get the first element, can someone tell me what I should put? How do I access the first element in my list? Maybe in chat. What is the code for getting the first element of our list? And again, our list is called nums. If I don't have an answer in 5-10 seconds, I will try to call on someone I haven't seen. So I see your message in Derek, nums parentheses 1. I think that looks good, but I think it's slightly off, but maybe let's see. Okay. Yeah, that's one part that could be fixed. So we have one answer, nums 0 like that. I put the fixed answer in chat, but Mason, can you help me? Do you see anything that might be a little bit wrong with that answer? Just look at the syntax, I guess. There's just one small detail that's off. Can you see what it is, Mason? So I'm saying this is close, very, very close, but not quite it. All right, so I see Derek, you change your own answer. Yeah, we don't use parentheses, we use square brackets. So getting the first element, there's two things to remember. Just the syntax of it, the characters that we write. We put square brackets, and inside the square brackets, we put the index of the element we want. So here, the index of the element we want is 0. And that's because indices, I wanna pound this into your head, indices start at 0. So the first element has index 0. The second element has index 1. The third element has index 2. So on, so on, so on. So getting the first element, we can do it like this, num0. Getting the last element can be a little bit trickier, depending on how you want to do it. So I say there's two equivalent ways of getting the last element. There's one that's a little bit shorter. There's one that's a little bit longer, a little bit more difficult. Does anyone remember one way of getting the last element of the array? Okay, yeah, Derek, I like your answer. Len of nums minus 1. So I assume how you got the answer is you can look at the pattern, essentially. If I have a list of 3 elements, what is the index of the last one? Well, that's going to be 0, 1, 2, right? So one less than the length. Same thing, if I have a list of 5 elements, what's the index of the last one? It's 0, 1, 2, 3, 4. 4 is the last index. In general, the last index is always just going to be 1 less than the length. And again, that's just because length starts counting at 1. Indices start counting at 0. So there's a difference there, a difference of 1. So we can get len, the index is just going to be the len of nums minus 1. And I like this answer. This answer is very safe compared to other programming languages. This is how you do it in like Java or C++ if you go on to learn that. It's very standard. There is a shorter way to do it in Python specifically. Python has a trick where you can do negative indexing. So, your indices go up by 1, 0, 1, 2, 3, 4. You can also do negative indexes. And so if you remember, or if you don't, you can also do nums of -1. So -1 just means the last element. It always is the last element. This is something specific to Python. It's not available in all languages, especially something like Java. You can't do this in Java. You'd have to do something similar to this, where it's the index equal to length -1. But anyways, at this point, we have the first and last elements. Now we just want to compare them to each other. And the comparison operator, we learned all the way back in the first or second class, it's the double equal sign, right? So the result is equal to first equals last. Right? And I'm going to group these terms together, right? And so when you use the double equal sign, this compares the left and the right sides. We take first, we take last, we say, are they equal to each other? If it is, this will be true. If it's not, they're going to be false. It's a Boolean value. So this thing in the parentheses is going to become a Boolean value, true or false. And then we just store it into a result. And then at this point, we're done. We have our answer. Our answer is result, right? If the first and last were equal to each other, this is going to be true. If the first and last are not equal to each other, then it's going to be false. So here we can just say return result, because that is our answer. That is the output that we wanted. The one last thing to finish up this program is here in the else block. We still need to return a value in all the cases. So if the length was not greater than 0, we still need to return an answer. And our answer here is just going to be false. It's the here return false. The answer here is just going to be false because our first condition, having the length greater than 0, it wasn't even satisfied. So of course the first and last can't be equal to each other. So I have to return false here. And so if we click go and run our code, you can see in all of the test cases, we will pass. Right. Here you can see all the different things it's running. Here are some of the ones that they already told you that they were going to run. And here are more tests that they just run to see if your code does the right thing or not. Just in case, Evan, I see you have your hand still raised. I know you were answering a question earlier. Do you still have a question now or, okay.
Oh, sorry, I forgot to turn.
No problem. I just wanted to make sure I wasn't ignoring you in case you had a question. Yeah, so that was one of the homeworks. The other one, cigar party. I can, let's check the time. I can write up a solution really quickly. I'll explain it. I'll post it after class as well. But I think if you understand the basics of how coding that works, this problem is about the same difficulty. It's maybe a little bit more difficult because it has 2 conditions. So here the instruction said, when the squirrels get together for a party, they like to have cigars. And we want to know if the party is successful or not. And whether or not it's successful depends on how many of these cigars are there. Usually, if you have any number between 40 and 60, you're fine, right? And so inclusive means that exactly 40, exactly on the edge, that's fine. Exactly 60, exactly on the upper edge, that's also fine. 39, 61, they're not, they're bad. However, if it's the weekend, then we don't have an upper bound. We don't have to limit between 40 and 60. It can be 40 and anything larger than 40, right? And so we want to return true if the party is successful and false if it's not, right? And so I'd say the first thing I want to check is it a weekend or is it not? Because depending on if it's a weekend or not, our condition is different. So if it is a weekend, we want to do one thing, something here. And then else, we know it's not a weekend, we do something different, right? And so based on just how the instructions were written, I'm going to do the else first. So if it's not a weekend, we're in this condition where we want the number to be between 40 and 60. So there's a couple ways you could do this. I'm going to do it in a way that has more lines. So I'm going to create one Boolean variable called greater than 40, right? And this is just going to be the number is greater than 40 or greater than or equal to 40, right? And then I have another condition. It's going to be less than 60. And so the other condition is this, it's less than or equal to 60. And I want to, the answer is just whether or not both are satisfied. So it's greater than or equal to 40 and less than or equal to 60. I want both of them to be true. So I have an and here. And then I just return the answer. If I look at the other one, if it is a weekend, it's going to be very similar. So I'm going to just copy my code. But the only thing that is different is that now we don't care about the upper bound. We don't care about it being less than 60. And so I just remove the condition. I only care if it's greater than or equal to 40 or not. And so if I run, you can see this works. And so I'll post this after class again to Google Classroom. We can take a look. But it's really just conditions again, making sure you're able to check the bounds of a number between two others, figuring if it's actually in between or not. So for today's class, I didn't have too much new I wanted to do. I think I want to keep practicing coding that, just because I think coding that is a really good resource, especially because it has just a lot of problems for you to practice. And so I want you guys to feel comfortable with the platform. I'm going to assign problems from coding that again this week. I don't know what yet. I will post it later. But we're just going to play around with this. And I think even outside of class, if you're bored, and I know it might be crazy, but if you're just wanting to practice some Python, feel free to go to coding that. I'd say anything that's listed like level 1, you should be able to solve at this point. The level 2 stuff requires something that we're going to learn next week. So if you want some Python practice, any of the ones, warm up, string 1, list 1, logic 1, these are all things that we know enough at this point to solve already. But I will talk a little bit of new stuff. I'll spend maybe 5 minutes talking about this new thing called tuples, but you'll see very quickly that tuples are not really something new. They're very, very similar to something that we've already seen. So tuples is a data structure, just like lists. And you're going to see a lot of things are about tuples are just like lists. The definition is that a tuple is a sequence of immutable objects. And the only difference between tuples and lists are that tuples cannot be changed. And tuples use parentheses, whereas lists use square brackets. So if you remember, when you make a list, you use square brackets. You say it's a list of 1, 2, 3, whatever. When you make a tuple, you're going to use parentheses in general. And does anyone know what immutable means, or make a guess at what this means? I think I mentioned it when we talked about strings. I said strings are immutable. Mason, I see you have your hand raised.
Immutable means like not able to change things.
Exactly. That's exactly the definition I was looking for. Derek, you said can't change order. We're going to see that's also true. But it's a little bit more strict than just changing the order. It's literally you can't change the tuple once you make it. So you can't add elements. You can't change what's already in there. And so that's the only difference between tuples and lists. With lists, we have the append function that will take a list and add something to it. A tuple doesn't have that because you can't change it. Once you make it, it's like that forever. Right? Earlier, we said strings were immutable, and that was because you can't just say like, you can't just make a string and then say, oh, the third letter of the string is now a B instead of an A. You can't do that. That's the exact same thing with tuples. So you can't just say, hey, this tuple has Frank 235 Tom. I can't just say, hey, I want to make this element 235. Now I want to make it 236. I want to add one to it. You can't. You can make a new tuple with that change, but you can't modify the original one. And so sometimes this is very useful. Sometimes it's not. Depends on the application. And so first, the things that are exactly the same. You access tuples in the same way. Notice I said tuples use parentheses. That's only for like printing it out and making it. When you're accessing tuples, you're still using square brackets. And that's just because in general, whenever you do anything with dealing with indices, you're going to be using square brackets. So here, if we're accessing at an index, we're using square brackets still. So where we made these tuples here, you can say T0 to get the first element, M2 to get the third element. Exactly the same as lists. So I won't spend too much time. This is where it's different. You can't update the tuple. Like we said, it's immutable. So you can't do something like T0 equals some new value. And that's just because if you try to do that, that means you're trying to change the tuple. And like I've said again and again, you can't do that. Tuples are immutable. Back to similarities, we saw that lists can be nested. You can have a list that has lists inside of it. Tuples, exactly the same. You can have a tuple that contains more tuples. Okay. You can mix and match them a little bit. You can have a list containing tuples inside of it. You can have a tuple containing lists, I think. Yeah, you can. So I think the more interesting part is just the discussion of tuples versus lists. Like when you'd use one over another, why do these two things exist? So one thing is, if you're really interested about performance, all right, the speed of which your code runs, tuples are slightly faster. Why is that? Well, tuples don't have to worry about you adding, modifying, any of that. So they're a little bit more like sleek, right? They don't have to worry about that. So they don't have to have this extra weight associated with it. They're a little bit more refined. So that restriction comes with some benefits, right? It's not all bad. So because you give up the ability to modify the tuple, you gain the kind of speed and efficiency associated with it. Again, it's very, 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 very minor, right? Get me clear. Like this will definitely not make any noticeable differences on any code that you're writing, or really any code that I've written. I've never really seen the effect of this, but it's slightly more efficient. So it's kind of interesting in that sense. I think what's more likely why you choose a tuple over a list is that tuples kind of add a layer of protection to your code. And so if you're writing a program where you never want the values to change, you want to put them into tuple. You don't want to put them into a list because maybe you aren't doing it on purpose, but even if someone just accidentally tries to change the values, if it's stored in a list, it would just go through and just change and you'd be in trouble. But if it was in a tuple, then someone goes and accidentally tries to change it, there'll be an error, right? When you run the program, it'll just say error, it's a tuple, it's immutable, you can't change the value. So you have that layer of protection. If someone does something incorrectly, it's just gonna crash. It's not gonna let them run it. Right? Also, sometimes we haven't seen dictionaries yet, but sometimes you require a type to be immutable to fill a certain role. And so a dictionary has things called keys and values. The keys in a dictionary have to be immutable. And even without knowing what dictionaries are yet, this should make some sense, right? It's a dictionary, think of it like a physical book dictionary, right? How do you use that? You find a word, you look up the definition, right? Well, if the word can change while it's in the dictionary, then it gets really weird because now, like, if you look it up now versus look it up later, you might have to look for different things. That just doesn't seem right. The key should always be fixed. Once you have the key, it should stay that way forever. And so when you make a dictionary, the keys have to be immutable types. You can't make a dictionary where the keys are lists because lists can change all the time. And so that's not allowed. Right? So that's really all I had for tuples. It's short because I think it's not really exciting, but it is something useful if you want to do it in your code. Tuples are just like a very close cousin of lists. They have a little bit more restrictions, especially namely that they can't be changed. But with that restriction comes with some benefits, some security, a few slight advantages. So I just wanted to put that out for you guys. So you have access. And I see Derek in chat, you said, why do you need them? Does it make sense now why we want tuples in addition to lists? Yeah. But that's a great question. A lot of times you do want to ask, like, do we really need this? Like, does this serve a purpose? Or does this solve a problem that we actually have? And so when it comes to tuples and lists, yeah, it actually does solve a problem of lists. In the remaining time, I do want to just kind of go back to coding that and just do a couple problems. I really do want to stress, like, I think the best way of really understanding what we've learned so far, strings, lists, booleans, conditions, if, else, if, and else, the best way to really understand it is just to play around with it. Right? And another benefit of coding that is it gives you feedback, right? Immediate feedback. You can try something, you can run it, it'll tell you if it's right or wrong. If it's wrong, a lot of times it'll tell you specifically, hey, with this kind of input, it messed up. Right? So let's look at the string ones because we haven't done a string problem yet today. And I think first half. So here, the problem is given a string of even length, return the first half of the string. So they give some examples. If you have the string woohoo, the output of this function should be woo, W-O-O. Because again, this string has 6 letters. You want to take half of it, so the first 3 letters, and that's W-O-O. Right? If you have the string hello there, that's 10 letters. And so you want to take the first 5, that's hello. If you have A, B, C, D, E, F, again, that's 6 letters. You want to take the first 3, that's A, B, C. So I guess, does anyone want to probably unmute and maybe talk through the steps needed to solve this problem? I don't need any code at this point, but let's just talk about how we would approach this. Does anyone want to give a shot and tell me how we want to do this? All right, okay, Derek, I see you have your hand raised.
So you should probably find the length first.
Yep.
And then half it, and then subtract 1 and then half it.
Okay. And then what do we do once we have half the length, or half the length minus 1?
You can make a variable for like half of the length and then print that variable. And
So
print substring.
yeah, so I want to focus on the substring thing. You're right. We do want to find the half of the length, but half of the length is not really what we're interested in. We're interested in the substring that is the first half of the original one. So how do we do the substring in Python, Derek? I guess. Like how, if we have a string, how do we get a substring out of it?
I don't know.
Okay, no problem. Does anyone else remember how we got a substring out of a bigger string? The technique was started with an S. I guess everything. Oh, Did someone say something?
Sort dot something.
So close, or we're not sorting. It's I'll give you what it looks like. So if you have a string,
Slice.
slice, yes, exactly. We're slicing the string. And so let me just again write out the variables. Slice the string, aka creating substring. And what that looks like is like if we have a string variable s, we're gonna do square brackets, and we have a start index, and then we have a colon, and we have an end index. And we talked a lot about how, sometimes you don't need a start index, sometimes you don't need an end index. We said sometimes you can have a third option, a step size. For this problem, we don't need a step size. And we'll get to the start and end index later. And so another way to approach a problem is you can always work backwards. So here we worked like first step, second step, third step. Another way to approach this problem is you can work backwards, right? We know we want a substring that is half the original one. And so to do a substring, we need to do a string slice. But to do a string slice, we need a start index and we need an end index. Well, the start index is pretty easy. It's just the start of the string. The end index is a little bit difficult, right? How do we get the end index? Well, it's going to be roughly the half of the length, right? And so that's why we need step 2. We need to half the length. Well, to half the length, we need to find the full length first, right? And so you can also work backwards in the things that you need to solve first. And like how Derek mentioned, we might have to like -1. I haven't really thought about it too much, but again, you have to be careful with when you're doing these slicings, whenever you're doing indexing lengths. Sometimes you have to -1, sometimes you don't, sometimes you have to +1. We'll see what happens in this. The best way to look at it is just to think over some examples. So let's go over the inputs that they gave us, like the string woohoo. Can anyone tell me the length of this string? I think I had mentioned it before. So Derek says 5. Let's get 3 answers in chat. What is the length of this string? If I call, if I do len woohoo, what is this going to give me? What is the length of this string? The 5, 6. So we have 5 and 6. Does anyone want to break the tie? Okay, I think Derek, you break the tie yourself. 6, yeah. So 6 is the correct answer. The length of this string is 6. And so half of this is going to be 3. So what if we just try now the string woohoo, and we get the slice from 0 to 3, right? Let's just try the half. What is this going to be? Does anyone know or want to make a guess? So you have to remember how string slices work. Do we include the letter at the beginning? Do we include the letter at the end index? So the answer is we do include the letter at the starting index. We don't include the letter at the end index. We go up to, but not including. So here we're doing the slice from 0 to 3. What is the character at index 3? Well, that's 0, 1, 2, 3. That's the age. So that means we go up to, but not including the age. And so this will give us woo, which is exactly what we want, right? And so here in our example, we step through it. We actually don't need to mess with +1, -1, but in some cases, you might need to worry about it. I do want to say the step 2, there's one kind of important detail that we have to watch out for. So I'm going to put a star on this step. But let's try to program this out. So step 1, finding the length. Well, the length is just going to be calling the len function. So the len function, and the input is here, str. So str. So that gives me the length, right? And so let's make another variable that's half the length, right? Equals length divided by 2, right? Half the length. And then I want to say the substring is now my original one, sliced from 0 up to the half, right? And then let's just return substring. So any predictions? This looks like we followed all the steps that we came up with. We stepped through an example by hand. Do you guys think this is going to work? Do you guys think this is going to have a problem? Maybe we overlooked something, maybe we didn't. Let's just see in chat. I want to see, do people think, is this going to work or is this going to have a problem? And if you're not sure, just make a guess. So Derek says not all the time. Then I'm curious, when do you think this is not going to work? So Charlie says not work. I guess if you think it doesn't work, we assume that the length is even. In this case, that's fine because the instruction said that the string does have an even length all the time. If we wanted to make this more general and support any length strings, including odd ones, well, first we'd have to define what the half of it means. Does half mean including the middle letter, or does it mean not including it? We'd have to figure that out, and we'd have to sort it out. But in our problem, it's even, so that's not going to be a problem in our case. So Derek, now you think it's going to work. Charlie, I was wondering, why do you think it's not going to work? If you can tell me. So, or if you're not sure, you can say that. Nothing wrong with that. Okay, yeah, perfectly fine to make a guess. I think it's good to make a guess before you know the answer. Because once you know the answer, you're gonna be like, oh yeah, of course that was the answer. I would have gotten it, or something like that. It's easy to not think too deeply about it. It's good to make a guess before you try it, and then see if your guess is right or not. Right? And it's perfectly fine if your guesses are wrong. So let's run it, see what happens. If you hit go, we'll see this is all correct. So this ended up working. However, I would say this is a little bit misleading because I have one issue with it a little bit. If we go to a different Python environment, let's go back to Colab. I'm going to make a new Colab notebook. If we do, I'm just going to make a new notebook and see what happens. One thing you always have to watch out for is something like this. If you have 6 and divide by 2, what do you get? You will get, if it runs, not 3, but 3.0. And so actually, I'm going to try this. I have a suspicion. Where's my code? This one. So I'm going to take this code, paste it. So why? I will talk about that very quickly. So I'm going to paste it into here. We define our function. And now I'm going to try it. The first half of woohoo. If I run this, if I run it in Colab, I'm actually going to get an error. And so this is actually, I was actually kind of surprised when it worked in CodingBat because I suspected it was going to fail. And so I think CodingBat might be either running their own special version of Python or they're doing some sort of processing in the backend. But strictly, if you had this, it's not going to work. it's going to give you an error. If you read the error message a little bit, it's a lot of text. And if it says type error, slice indices must be integers or none, or have an index method. So it's really complicated, but the crucial part is here. Slice indices must be integers, right? And if we look at what we saw here, if we do a division like this, 6 divided by 2, we get 3.0. Does 3.0 look like an integer? It does not, right? Integers shouldn't have this decimal point. And so that's where this comes in. And this is why I put the stars. When we're doing length divided by 2 here, we have to be a little bit careful. Even though we know that the length is even, we know it's divisible by 2. If you do length divided by 2 like this, it's gonna be by default a decimal. Whenever you do division in Python, it automatically does like a floating point division or not integer division. And so, yeah, so Derek, I see your message in chat. You can use a double divide sign to do integer division instead. So if we look at this, I'm gonna print 6 divided by 2, and then I'm gonna print 6 divide 2. And notice the first one gives us 3.0, the second one gives us 3. And what we further can do is there's one function, not super useful, but sometimes it's nice. There's a type function. The type function will just give us the type of whatever we put in the parentheses. So I want to print out the type of 6 divided by 2 and the type of 6 divided by 2. We look at that. The first one's a float or a floating point number, has a decimal point. The second one is an int. Okay? And so that's one way we can fix it. We can do divide by 2. And now if we run the same stuff again, we'll see that the function now does work. All right, we can do the. So I would say this is the better solution where you use the integer division. It just divides and makes sure it's an integer. There's actually another way to do this since we learned how to convert things to integers last week. Another way to do this is just to do divide by 2 like normal and then say int around it. And so when you convert a number to an int, we can play around with it right now, but I'm pretty sure it will just truncate. So if we do int 3.2, it will give us 3. If we do 3.9, it will still give us 3. So be careful here. The int function that we use to convert like inputs to strings to ints can also be used to convert floating point numbers to ints. However, it does it by truncating. It just drops the decimal. So even if it's like 4.999, it will drop it to 4. Okay. But either way, these two solutions both work. You just have to be careful that whenever you're doing something with indexing, slicing, anything like this, you have to make sure that everything's an integer. And if you just do this normal naive division, you can have problems sometimes. Just taking time. I think I'm exactly out of time. Again, hopefully going over today helped you understand how coding that works, and a little bit of conditions and tuples. Next week, we're gonna talk about loops, which I think is the last important thing for Python 1. And it's a really powerful thing. So that's gonna be, I wouldn't say a difficult lecture next week, but it's gonna be a packed one. So be ready for that. For this week, I will choose a couple more coding back questions just to practice what we've covered so far in the first 7 classes. I'll probably pick like 2 or 3, just like last week. Take a picture of this results screen just to show me that you did it or tried it, and that should be good. So I won't hold you longer than that. Thank you for joining me, and I'll see you next week. If you have any questions,